All right. So a lot of things have changed since I did that bio and everything like that. But today, like, who here works in like front-end web development? A lot of people. Okay. Who has tried to solve like creating an application store, maintaining application state inside your application? Did you do that by rolling your own solution, or use something like Redux or NGRX if you're an Angular fan? Like you had to come up with some solution. So today I'm gonna talk about sort of open source solutions that are out there that will kind of do a lot of the heavy lifting for us, and then ways that if our application's fairly easy, we can just kind of use our generic JavaScript or use like RxJS to kind of do that for us. So first off, my name is Joshua Godi. I also no longer work at Bullhorn. Come Monday, I'll be starting at Netflix. So over this weekend, I'm actually moving out to California and everything. So lots of changes. I'm an instructor at Angular Bootcamp. So if you're curious about Angular training or anything like that, reach out to me afterwards. We can get you in an Angular Bootcamp class. You can find me on Twitter there, or there's my email. And there's my trusty sidekick, my cat, who's always there, I guess. So what we're actually going to cover today is a lot of things. We're going to first talk about what an application store is and what that means, why we should want something like that in our application, and then how to get started. We're going to cover all of the different open source solutions that are out there. So I'm going to try to cover all of the different frameworks that are out there. So React, Vue, Angular. I'm going to cover some just vanilla JavaScript solutions. One that if you utilize GraphQL, you can utilize that. So a lot of different things. We're going to go shallow in a lot of different open source solutions. Then we're going to dive into how we can roll our own solution, and then show how using an application store will affect the flow of data in our application. And then just go over a couple different use cases at the very end. So first off, what is an application store, right? So I like to think of it as like a container for the data in your application. The data that your application is going to produce and also consume. That way there's one source of truth in our application, and we can just refer back to this store. And this store should give us the ability to subscribe or react to different parts of data in different parts of our application, right? We don't need our whole application data in like a little card widget. We might only need the name and breed of a cat, for example. And I like to use our store as like one place where we're going to do all of our communication to our REST APIs, and then also handle any business logic. Traditionally, I like to push all of my business logic down into the server, but there's use cases where some of that bubbles up to the client. We might have to do some massaging of data. I do that in my application store. That way, my component layers, my display logic, only deals with display logic, right? We don't have any business logic embedded into our display views. So why should we care about an application store, right? This is going to simplify the flow of data in your application. So those of you that are familiar with Angular, the newest versions of Angular, you have inputs that you pass data down, and then outputs to pass data back up. So your application can get fairly complex fairly quickly if you have 10 layers of components in there. You're passing data all the way down, and then you're using actions to flow all the way back up. So this is just going to simplify the flow of data. Like I said before, it creates that one simple truth in our application. So where we put the data, that's where the data lives. That maintains our data integrity across our application. That way, if one component over here needs a little snippet of data, but this component over here also needs that snippet of data, we can keep them aligned with the same value fairly easily. And this basically keeps your components clean of that business logic. So they can just focus on display logic, and it makes our application a lot more easier to write unit tests on and acceptance tests. So how do you choose and implement a store like this? So I'm going to go over a few considerations that I personally use when it comes to creating a new application and then maybe even refactoring an older application to use a store like this. A lot of these generate, like generally you're working with your team to kind of go over the pros and cons of each one, right? Because using a third-party open source solution comes with a lot of boilerplate code and a lot of dependencies we have to pull in. Maybe that's not what we want as like a team for this application. And then I also like to consult the documentation, right? So if we're using a third-party solution, like what's the support for that solution? How are pull requests being reviewed and merged in? Does it have a big following? Because the worst thing you can do with your application is pull in something in that's like third-party open source, and then in a couple of months it's dead. And then you end up maintaining it yourself because your application's huge and you can't just pull it out or like replace it. So you do a lot of like homework and investigation work on GitHub and Google Trends and things like that to determine if a third-party solution is the best for you. Then if you're rolling your own, if you're spinning up a brand new application, then it's easy. You just kind of start with whatever components you're creating with. If you are trying to convert an older application to have like an application store, then we just start with like the smallest pieces first and then slowly grow it over the course of improvements we're doing throughout the project. So here are a few considerations that I like to go through. First, I like to consider the data flow. Like, how is data actually flowing in our application? Do we have a lot of child components that need access to the root application's data? Or are we just flat, right? Where we just have page and then another page. There's not a lot of communication. So how is data flowing in our application? And then I also like to think of on one page, how many different components are going to use the same data, right? Do I have a card over here and a card over here that use same parts of the data, or they use different parts? Do I need to keep them in sync, and how am I going to control that? The next thing I like to think about is how we're actually going to the setup process, right? So how important is it the ease of setup for yourself and your team, right? When it comes to like a third-party solution, sort of maybe like a Redux solution, there's a lot of boilerplate code that comes along in it. You have actions, reducers, the store, and there's a lot of boilerplate code that happens. Are you comfortable with that, all that boilerplate when you're spinning up a new feature? So all of those kind of go into play. And there's ways to reduce the boilerplate code, right? If you're using the Angular CLI, you can make your own generators. You can write your own CLI to kind of generate those files for you. So like, how much boilerplate code, how much sort of DevOps are you willing to do to write some of those code generators for you? And then lastly, I think of the complexity, right? So how complex is your application? Like, is it really just I do one REST call to go get the data and I display the data, then I click a link, I do another REST call, it's a whole different set of data. So just thinking of your single page web application, like how is your data flowing, how complex your application is. And is debugging your data important to you? There's those open source solutions like Redux, they have those Redux dev tools where you can kind of actually go through and time walk your application through and kind of watch, see, when I change this value over here, it affected here, and you can kind of slide the time and kind of actually see what happened. And then again, like how many developers are going to be contributing to your application, right? This falls into the complexity and boilerplate code setup. And then how important is it to have like a quick onboarding for new developers on this application? So all of those considerations go into my mind when I'm architecting out a new application and sort of how I need to store and save the application data. So here are a couple of the open source solutions that are out there. Who here has heard of Redux for React? All right. What about NGRX? So Vuex. So we have a lot of different people there. I try to cover all the top 3 frameworks. Those are all sort of a Redux pattern, and we'll kind of go over sort of what that looks like. There's also, in the Angular land, another solution called ngXS. It doesn't really follow the same Redux pattern. In the syntax, there's a lot less boilerplate code. The syntax feels a lot more Angular-like. There's more annotation-based when you're grabbing your data from the store and things like that. In React land, there's unstated, which uses the new React's context API, which is pretty neat. If you are someone that doesn't like any sort of framework or library to use, there's Akita, which is just written in pure JavaScript, which sort of follows almost a same Redux pattern. And then if you're using GraphQL, we can use Apollo link state. That's like an add-on on the Apollo library to sort of cache our data that we're requesting in GraphQL. So let's take a quick dive into sort of what Redux looks like, right? So we're going to look at Redux, NGRX, and Vuex. They all have the same paradigms and data flow, basically. So here's a little annotation or a little GIF of animation of sort of what a Redux-style data flow looks like. So the bottom left, this is our UI, right? So we're clicking the button to deposit or withdraw. When we click the button, our UI is going to fire actions into our store. And these actions will have a type and some data associated with it. And those actions are going to go into the store. They're going to hit the dispatcher, which the dispatcher is going to say, hey, I have an action that I need to respond with. It's going to grab the current state out of the store that's responsible for that type of action. It's going to pass both the action and the state into a reducer. And a reducer is basically like a mapping function, right? So you can think of a reducer as a way where you take data in and it's going to push data back out. It's just a pure function. It's going to be probably deterministic, where, say, you take in the state, which could be our balance, and we're saying I'm going to deposit $10, so it's going to take the balance plus 10. Or withdrawal 10, it's going to do balance minus 10. And it's going to persist that result back into the state, and then the state will then push the new data into the UI. So you see we kind of have that whole flow in our application. This is the Redux pattern. And then we have something more along the lines of ngXS, which is a little bit less boilerplate code to kind of deal with. And it handles our application state a little differently. But you see we sort of have the same components in here, but just named a little bit different, right? We have our component on the left. It's going to dispatch actions. Those actions are now going to go either to plugins, which is sort of like our reducers, where it's going to modify the data and mutate that into the store. It can also communicate to a backend. So say if our component fired an action, we needed to go get more data from the backend. We can do that here in the action, communicates with the backend returns whatever data that it needs to, then it mutates that new state into the store. And then finally, the component has a selector annotation on it, or a decorator, and then that's going to say, hey, select me the list of cats from the store. And then as the cat list gets mutated into the store, it's going to emit that back to the component. So that way, our components, we don't have to pass anything down into it. We can just subscribe to different parts of the store. And then we have Akita, which was that just pure JavaScript solution. And then here, basically the same thing. We have our store up there. We have our component down at the bottom. Our component's going to now use what they call queries, which is basically we're querying for a specific piece of data from our store. So in this case, we could say our component's going to be listening for the cat list from our store. And then another component in our application can emit an action that says, I'm adding a cat to the cat list. That's going to go to a service, which could persist that data into some backend REST API. It's going to fire an update into the store, which will basically just do like an array.push on our cat list that we have. It's going to stream that data back down to any of the queries that are listening to the cat list from the store, and then it's going to re-render the component. And here the queries can interact with other queries, so you can have compound queries and things like that. But you see we have that same sort of flow throughout our application. Our component will subscribe to a part of our data. That will go into a service or like a reducer in our store that will persist the new data in our store. And then our store will push an event to our component that says, hey, here's my new data. You do something with it. And then one more for the Apollo link state. So who's familiar with GraphQL? A couple of people. So GraphQL, when you're using this inside of your UI, whether it be React, Angular, or Vue, you kind of forego all of those traditional REST APIs to go get data from your server. Instead, what we do is we actually write queries into our GraphQL server. Our GraphQL server, which sits on our server somewhere, will then communicate with another REST backend, do SQL queries, or communicate with another GraphQL server, and then parlay that data back up to our client. So we don't have to have specific data or specific REST endpoints for, hey, get me a cat list or get me a specific cat. You can fetch only the data you need and don't have to worry about overfetching. But what the Apollo link state does is when we're doing all of that communication, it's going to store those results locally. So then when we do another request, it sort of acts as like our application store. And then it won't actually communicate out and do things like that. So it'll basically cache and normalize all of our data. So pretty cool if you're using GraphQL in your front end. And then there's also ways where you can roll your own solution, right? Rolling your own solution was just all in pure JavaScript or TypeScript, whatever you want. I'm going to cover two different ways. One is with no dependencies, so that we're just going to utilize a generic pub/sub method that we're going to store basic JSON objects to persist our application state. And then I'm also going to use RxJS. RxJS is it's just a JavaScript library. It's framework agnostic, so you can pull it into React, Vue, Angular, wherever you want it. And we're going to utilize their subjects to sort of store our application state and use observables to subscribe. So the first one, this is our native solution. And so this is going to be zero dependencies, just pure JavaScript. And hopefully that's big enough for everyone. But basically we have two parts to a native JavaScript solution. A part that I call the publisher, which is just going to have an object of events, and then a subscribe and publish method. And what this events object is going to be, it's actually going to be a JSON object that'll have a key, and that key's value will be an array of subscribers to it. Basically callback methods on this event object. So when we subscribe to a certain event, say like cat list, for example, we're going to give it a callback. So when a cat list event gets fired in our application, we want this callback to happen. So then we check to see if the events object has the event that we actually want to subscribe to. And if it does, we just want to push that callback on there so that we just end up with an array of callbacks that need to be fired when a certain event is fired. And then we have a publish event. This publish event is going to take the event name, so like cat list, for example, and then data. And then that data is going to be whatever you want to be fired in every single callback. So this will be the current application state. And then here we just grab the events at whatever event, the event name. And then since that is an array of all the callbacks, we map over it and then just call the callback. So here we're utilizing the callbacks in JavaScript. And then we have a store, which is going to maintain our state just as a JSON object. We're going to have an events property which is going to just be the publisher. And then we're going to utilize the proxy object. So who here is familiar with the proxy object in JavaScript? A couple people. So basically what a proxy object in JavaScript is, we can key into a lot of those core functionalities, so like getters, setters, anytime we're mutating the state, or basically anything that happens on that object we can tie into and then do additional logic. So here we're making the state as a new proxy. We give it the target, so here it's just an empty object because our state initializes to be an empty object. And then we're just going to basically mutate the setter. So anytime that we're setting this dot state equals, it's going to go into our proxy, and then we will give the state, which is the current object we're mutating over, the key and value, since it's a JSON object. And then anytime we set this state object, we're going to set the state and the keys in our local variable here. And then we're going to use that publisher we created to publish a state change event for this dot state. And then here, like instead of state change, you can key into whatever the key is if you wanted to do only specific parts of the data. But in this example, I just made it pretty generic and says anytime the state changes, just publish this event, and then you just return true. We can also do like mutate the getter, so anytime someone tries to access the object, if we wanted to fire an event, we could do that as well. And then this store just has a setData method that takes in a key in the payload, and then we're just using the object spread operator to put that onto the state object, and then we're going to return true. So here on line 36, when we're doing this assignment, it's going to go into our proxy, go into the state. It'll actually persist the data how we want it, but then it'll also publish an event on our events publisher. And the way that we can use this is we can create something like a cat store, just saying equals new store. Then we can subscribe to something like cat list, right? So that we're pushing that callback here, which is just an array function, onto that array for any time the cat list event gets fired. We want to do something with the cats. So here, this is where we would update our UI, re-render the table or list, anything that we wanted to do. And then in our cat store, we can set the data, cat list, and then give it an array. So here we do cat1 and cat2, and then that will fire into our store, which will fire the event, which will hit in our subscribe, and it'll actually render our cats. And then if you just wanted to get the current state as of right now, we could just say catstore.state.catlist. Since it was just a generic JSON object, we can just grab it wherever. So now, my personal favorite when I'm rolling my own is I use RxJS. It makes it a lot easier to follow and sort of understand. So this example here, we're importing some things from RxJS now. Observable and behavior subject. So for those of you that aren't familiar with observables, everyone should be familiar with like the JavaScript promise, right? Where we say .then, we give it a success callback and then a failure. But that promise is just a single point, like, hey, go get me data, it's going to return. An observable is basically data over time. So you can think of it as like a timeline. And then the observable, when instead of doing a .then, we're going to do a .subscribe. And then that subscription can be fired multiple times during the life cycle of that observable. So you can think of it as data over time for an observable. Then a behavior subject, I like to think of it as just a wrapper around the observable, but then it also stores some initial state. So it gives us pretty easy access to mutate that state that it's storing, and then firing on that data over time observable. So here we're utilizing TypeScript in here. So I just have an interface that represents my cat. So my cat just have name, age, and breed. And then I create a cat store. So here on line 10 and 11, we're creating those subjects for a cat list and a selected cat. And then we're just creating them to be new behavior subjects. and then giving it some initial state. So here we're doing an empty object or empty array for the cat list and undefined for the selected cat. And then on line 13 and 14, we have two read-only properties so that our users can never overwrite those. And then for cats and selected cat. And these are basically going to be the observable that is behind that behavior subject. So we just take that subject and then call the as observable so that we can subscribe to these two when we're actually utilizing our store. And then I like to keep line 16 and 17 here just as our internal state in our store. So anytime that we actually want to grab the current state or anything like that, we can do it pretty quickly. And then I usually have a couple methods to sort of initialize my store, right? So when my application loads, I'll create a new store. I'll call something like on line 19 to retrieve the cat list, which this is just going to return our read-only property for the observable. So it's going to return this.cats. But here we'll do any HTTP call to our server that'll say, hey, go get me all the cats that you know about. It'll come back to here, and then we will call next on our behavior subject, which will fire another point on our timeline of data for the cat list. And then the same thing here for add cat, right? So add cat, we're doing all of this on the front end in this example, where we just mutate that cat list array. So we're just pushing onto it. And then we call next on the behavior subject, which just fires that next iteration of that observable. And then we just give it the whole cat list. The same thing goes for the select. Here we just store our current state. So we're updating the selected cat object. And then we call next on that behavior subject. So you can see how you can kind of rinse and repeat this for all the different pieces of data your application uses. So cat list, selected cat, kittens, other cat-related things would all go into this cat store. And the way they would use this is much like the way we use the other one, is we're going to import the cat store and the cat interface from our cat store file. We're going to initialize a new cat store. And then instead of doing those callbacks, we're still going to subscribe. So we're going to say store.cats, which is that was our observable. And then we're going to subscribe. And like I said, it's much like a promise. You have the success and the error block. But here we're only dealing with the success block. And then we're going to say, hey, whenever I get new cats, then call this method, which is going to have the full array of cats there. And then we could store it as a local variable. And if you're using like Angular or Vue or React or something like that, you would update the state there, update your props or whatever you need to do there. The same thing with the selected cat. We subscribe to that. And then anytime the selected cat updates anywhere in our application, we can just subscribe to that one piece. And then we can display the name, the age, the breed, whatever we want to do based on when that cat changes. And then the way we're going to trigger those is, remember in our store we had that add method, right? So we call store.add, and we just give it a JSON object that represents our cat. That is going to go into our store, push that onto the cat list, and then it'll call next on the cat list subject, which then will fire into our observable here. We'll subscribe to the data on our observable, and then we'll have the cat data there. And the same thing if we wanted to select the cat, we call the select cat method with the cat we want to select, and then it'll go into the subscribe method, and then we can update our UI however we want. So we talked about a lot of open source solutions. We talked a lot about how we roll our own solutions, but how does this actually affect the flow of data in our UI, right? So I always like to use this diagram. So on the left-hand side, we have the before. So if you're using something like Angular, React, or Vue, your application probably looks a lot like this, right? You have your root component, and then your root component will render another component. That component renders 3 or 4 other components, and you end up with like a component tree for your application. And the way that you have to pass data down into them is in Angular, like inputs and outputs, right? We're passing data down to all the way down here to the yellow block, right? And that's rendering the cat name. And then anytime, say if this yellow block had a button to say, hey, I want to select this cat, you'd have to bubble up all the way to your top level of your application and then bubble back down if you wanted the selected cat to be rendered on the right side of the tree. So you can kind of see how our application flow is very difficult to manage and debug. At any point in time, something could go wrong in any of these components that it breaks the flow of data, and then now we can't render any of the data down here. So in comes our application store, right? So now, instead of passing data all over the place, every which way that you want to, we just have all of our data in our store. And then all of these components just subscribe to those different parts of your store. And then here in the yellow block, we have the select cat method that fires that next on that behavior subject, or it fires a selected cat action if you're using like Redux or anything like that. That goes into the store. The store then will update the state, and whoever, depending on who's subscribing to the state, what part of the state, each of these components will update. So you see, we break down the application, the data flow in our application into something much more manageable and much more easier to debug and add new things to by utilizing like an application store. But how do you pick the right thing, right? A lot of you probably came in here thinking that I was going to tell you, you do this, you do that. But a lot of these just come down to like personal preference and team preference, right? I might be really gung-ho about Redux, but another person on my team might hate all of the boilerplate code that comes with Redux. So it's just working with your team and vetting out sort of the solution that you want based on those considerations that I covered earlier. And then really vetting out the open source projects, right? Like something like Redux is probably going to be there to stay, but there might be a smaller open source library out there that you really click with when it comes to application store, but you just look at the community, the support, how they handle issues, right? If there's thousands of opened issues on a project, chances are you probably don't want to use that because there's not a developer maintaining that project. And then again, you look at your application, right? Is it a really simple application? Then you can either not use a store at all or roll your own solution. Is your application very complex, like an e-commerce application where you have a centralized shopping cart and you can add things to the shopping cart any which way, then chances are using something like Redux or Unstated or something like that could be extremely beneficial. Will you benefit from the open source? Do you want to just use open source so you don't have to worry about all of the different challenges that comes with rolling your own? Right? We saw in our rolling the own solution, we had to add code every single time we wanted to just add a new thing in our store. To say if I wanted to store the current age of the selected cat or something like that, I have to add code for that. With something in the open source community, we can just add a new property and we can grab that pretty easily. And if it's not worth all the setup, then you can roll your own. And if you're sharing state a lot through your application, consider something that's open source. So it all really boils down to sort of something that you guys can all understand and your team can understand, and then sort of how comfortable you are with open source versus rolling your own. So now I want to go over like a couple different use cases, right? So that we can really drive the concept home. So the first use case, so say if I'm a developer and I get a thing from my project manager that says, I need this new application that's called Adopt a Kitten, right? This application is going to be 2 screens. One screen, when you first load it up, is just going to be a list of all the kittens that can be adopted, right? And then when I click on one of those kittens, then it's going to go to a details page that probably has a whole bunch of cute, adorable photos of the kitten, and then some details about like where they came from, breed, etc. And all of this is read-only. There's no really like editing or anything like that in the application. What would you guys think you would do in a situation like this? Would you sort of roll your own solution, not use an application store, use a third-party solution? What do you guys think you would do in this scenario? No store? Let's see what I said. Oh, it's supposed to be here. So, what do you think? Let's do it again. What do you think? So here, this is what I would roll my own store, or probably not use an application store at all. And the reasons being is because there's actually really no data flow in the application, right? You just click on something and you render a new page. Yeah, there's optimizations that we can do on the front end, right? Say if we click the same cat 10 times, it's going to do 10 REST calls every time we fetch those details. So using something like a store to basically maintain a list of cats we selected, and then when you load the details route, you can say, hey, is this in my cache versus not? So something like that we can utilize. Something like what we saw before with service workers, we can cache those results so it doesn't actually go to the server at all either. But here, this is where I would probably try to go no store at all, because there's no adding or editing. There's not really a lot of data flow in our application to make it really complex. And then now my project manager is also like, hey, I need this thing called the kitty catalog, which is just a one-screen application where on the left side of our application, it's a list of all the kittens. And on the right side, as we click on a cat, it loads some details and like a header component that has the name, and then a bio component that has all of the breed and age information, and then like the pictures and stuff. And then also over there, they can click on an edit button that loads a form, and they can edit the age, breed, name, etc. They click save, and then it should change all in our application. So what do we think we would do in this solution? So here, this is where I would either roll my own, or I would choose an open source solution. I would probably choose an open source solution like Redux in this case, because we have so many different components that are using same parts of the data. In that solution, I would maintain the list of cats and the selected cat in like the cat store that we just saw, and then I would utilize those actions. So instead of the list directly communicating with our details component, it would fire an action that says, hey, I selected a cat. That would go up to the store, and then that would mutate the selected cats part of the store, and our details component would subscribe to that and then reload. And the same thing when the cat is updated, right? We would fire a cat updated object, which would mutate our list and maybe our selected cat if those IDs matched, and then different parts of our application could update. All right, any questions? Yes, I'll make a link and make them available. And if there's no other questions or anything, you can always reach out to me on Twitter or on GitHub. Or I didn't put my GitHub on there, but my email. But thank you. It all depends on sort of what the component actually is doing, right? So if I was in a use case where a component was subscribing to like 20 different parts of the store, then I would sort of take a step back and say like, what is this component actually doing? Like, should it be broken up into subcomponents? When I'm creating a UI, I like to think of it like try to make as many small reusable components as possible, and I like to break them up as what I call like smart components and dumb components. Like smart components, this is where you would subscribe to parts of the store, right? And then dumb components, you just pass data down into them, and they just render in HTML, CSS, display JavaScript. So I'll try to break my application up as small as possible. That way, you're kind of future-proofing your application, right? So say if that same project manager was like, well, now I want this new screen that does this, this, and this, we already have those reusable components that we can just kind of like, oh, it's easy, versus having to go back and refactor those components out to be shared components and then having to retest that part of the application and that. So I tend to try to keep them as lean as possible. No problem? Yeah. Yeah, we, well, I haven't worked there yet, but they use the Apollo link state. It all kind of varies on team to team. So Netflix is React. So some teams might use like the unstateful or Redux. My team will use the Apollo link state. Yes?
What are best practices for reconciling data between like new state coming into the store versus what's persisted like in the database? Do you let like the state that is coming in be kind of sort of truth, or and just handle like error connection error and testing error? What advice do you have for that?
So if I'm like in an application, like another thing to consider is like data churn, right? Like, are there a lot of other users of my application that could change the data that I'm viewing, right? If that is true, so like at my company, like my old company, Bullhorn, a lot of like they could change the candidate's information or the company's information, and I'd want to see that the next time like my page refreshed. So something like that, I would use like an open source solution. And something like those in those reducers, specifically in like ngXS, where you can communicate out with another server, I would persist that and then have that REST API return the new data, and then I would use that in my store. I wouldn't try to reconcile state in my front end, because then you could be unsynced, right? So anytime there's a lot of data churn in my application, I'll always go to the REST API, come back, store that result in the store. All right, any other questions? All right, well, thank you, everyone. It was great talking.